Lesson 5.7 is going to actually work a lot with radicals today, just like we did with 5.6, but today a little surprise. Take a look at the top of the notes. The square root of -9. If you were to enter that into your calculator, you would get an error message more than likely. Really, this in the real number system would be undefined. And the reason is there is no real number times itself that's -9. Now, at first glance, you might think that you have found one. You might think I'm thinking of -3. But -3 times -3 is a +9. So actually, we're going to investigate this further. We're going to actually say that you could come up with a solution, but we're going to work with imaginary numbers. The square root of -a is called an imaginary number. As soon as you see a negative inside of a square root, we're going to represent that in a very special way. Here's how. The square root of -1 we're going to call I. And of course, inside the radical of -a, we could think of this as -1 times a, and we could separate that. The square root of -1 is actually an I, like we just said. So we could write this as I radical a. And in fact, I'm going to put a big star, or a few stars over here. Whenever we have a negative inside of a square root, take out an I, and you'll be left with radical a. That I is going to really remind us that we're working with an imaginary number. Now, if I is equal to the square root of -1, if we were to square both sides, we'd see that I squared would equal, well, look, squaring a square root will just make the square root go away. So here's a very important definition. We're going to use it a lot in just a few minutes. But these are two super huge pieces of information we're going to use all throughout the lesson. I squared is -1, and whenever you see a negative inside of a square root, pull out an I, and then reduce or simplify your radical as we did in lesson 5.6. So, for example, if we had the square root of -4, first thing that we do is we very simply take out an I. We'll have I radical 4. But the square root of 4 is really just a 2. Instead of writing I times 2, however, we're going to put 2 times I. Just as we've been doing all throughout algebra, if we have a variable multiplied with a number, we'll put the number out in front. If I have the square root of -15, I'm going to pull an I out here as well. Now 15, very simply, is 3 times 5. And we're not going to be able to find any of the same factors. You won't get two factors that you can pull out. That would be as simplified as we can go. Similarly, over here with the square root of -20, take out an I. But now, just as we did in the other lesson for 5.6, look at 20 and think of two numbers that multiply to 20, namely like a 4 and a 5. Here we'd have a 2, and a 5. 2 times 2 times 5. So what this really will allow us to do now is to simplify the square root of 20 just like we did the other day. Look for doubles. When you see two of the same factor, pull it out. We still have a 5 inside the radical. We only have one 5 inside, and you'd need two of the same number to be able to simplify it out. A complex number is a mixture. It's a real number added or subtracted to an imaginary number. So what you can see down below, a few examples. 3 plus 2i, 4 minus 5i, numbers like that. Well, we'll talk about that in just a moment. But first, let's just do a couple more examples. If I gave you the square root of negative 24, let's pull an I out, and we'll have the square root of 24 still inside. 24, you could say, is 4 times 6. 4 is 2 times 2. And 6 is 2 times 3. Again, we're looking for prime factorizations. You can now see that there would be 3 2's multiplied in succession and then a 3. I would have 2 factors of 2, so I will pull a 2 out. But inside I have a 2 and a 3. 2 times 3 is 6. So we would have 2i root 6. This other problem, for number 2, again, pull out an I. Break down your 18. 18 is 2 times 9. 9 is 3 times 3. So again, a lot of review from the previous lesson, which is great. We get a little more practice with that. Do prime factorization. You can see that you'll have 2 3's. Out comes a 3. You'll have 3i root 2. Well, solving. Just as we did in the previous lesson, we're going to solve here just as well. X squared equals negative 20. Well, you know what? We're going to take a plus minus square root of negative 20. And when you see this, again, take out an I. Pull an I out. Now with the 20, we actually broke that down before. That's 4 times 5, and of course here's a 2 times 2 times a 5. So we have plus minus I, 2 times 2 times 5. Out comes a 2. Put it out in front of the I, and leave the 5 inside the square root. Tell you what, let's skip number 4 for the sake of time. Again, we have limited time here. Jumping to number 5, though, it's a little more complicated. That's why I'd like to focus more on that. Get x squared alone, minus a 7. As you subtract a 7, negative 17 minus 7 is negative 24. Divide by a 2. You'll have x squared equals negative 12. And here we go, just like we did with number 3. Take your plus minus square root, and we will have x is equal to plus or minus the square root of negative 12. Well, again, take out an I, and you'll have plus or minus I root 12. But 12 is 4 times 3, and this is 2 times 2. So in a prime factorization, we'll have 2 times 2 times 3. Again, here are 2 2's. Pull that out in front of the I. Here's 2i radical 3 plus or minus 2i radical 3. On the back, long lesson today. Adding or subtracting complex numbers. Now, here's the neat thing. Adding. As we look at example 1, please don't think that you are multiplying or foiling these two. Notice that there is a definite direction to add. Now, even if a student were absent for this lesson, and if they never even saw what an imaginary was prior to this lesson, they might guess that they would simply combine like terms. And that's the wonderful thing about this. This is essentially what we're going to do. We'll add our real numbers. 4 plus 3 is 7. 1i minus a 4i would be a minus 3i. And unbelievably, we are done. Take a look down below. Very similarly, adding just means add the real components together, namely the 3 and the 7. Add the imaginaries. A 6i and a minus 4i would add up to a 2i. Taking a look at number 2, however, as we're subtracting, you need to remember that here, these parentheses are very, very special. We're going to have to distribute a negative. As we say in class all the time, DTN, distribute the negative. We'd have negative 5 minus 2i It says if there's a negative 1 here that is being distributed, it will change the sign of everything inside that second parenthesis. We'll have negative 6. Negative 1 times negative 7i is a plus 7i. Now add up your real terms. Negative 5 minus 6, is negative 11. Negative 2i plus 7i is a positive 5i. Very similarly, over for number 4, distribute this negative. You would get negative 3 minus a 2i. Again, add your real components. 16 minus 3 is 13. Negative 4i minus 2i is a minus 6i. Moving on to the last part of the lesson, multiplication. Remember that I squared is equal to negative 1. That was one of the main ideas of today's lesson. I squared is negative 1. We're definitely going to need that. Here is why. We distribute. This is now multiplying. 2i times 4 is an 8i. 2i times I is 2i squared. But like we just said, I squared is negative 1. So whenever we see that, you must replace your I squared with a negative 1. This would be 8i plus a negative 2, because 2 times negative 1 is negative 2. But notice what is the convention for complex numbers. We put the real number first, and then have the imaginary number follow that. Last problem, FOIL. 7 times 3 is 21. 7 times 4i is 28i. Negative I times 3 is a negative 3i. Negative I times 4i is a negative 4i squared. But here we go again. By the way, we're going to need this information for the next lesson as well. The I squared is always going to simplify into negative 1. You must simplify it. Negative 4 times negative 1, of course, is just going to be a positive 4. I could have just written minus times a negative is a plus. But look, 21 plus 4 is 25. 28i and minus a 3i is a positive 25i. Look at that. We are done. The next part of the lesson for 5.7 is on division. We're going to have a separate YouTube lesson for that. But hope this is helping. Good luck to you.